All right, welcome to Unit 4, Lesson 1, Part B. We have solving systems by graphing, some special cases. We've only discussed one solution where the two lines intersect in one spot. That's our one solution right here. One solution. You have intersecting lines. But there's also two other types of lines that you might encounter. You might encounter lines that are they're moving with a slope that's the same or the same rate of change. As they rise, they run at the same rate. So this line is rising and running as this line also rises and runs. So in that case, you might have a no solution, a second situation. So if we think of the equation in slope-intercept form of y equals mx plus b. M is the slope, b is the y-intercept. In this situation, this line here has a slope. We'll call it m1. And this line has a different slope, m2. So if the lines intersect, there's only one solution. This means the slopes m1 and m2 are different. And as I said before, I've pulled this out of a text that's not ours. So you can see here that when you have intersecting lines, the big difference here, they have different slopes. If you look at the second situation, these lines are parallel. That means the slopes are the same. However, look where they are when they hit the y-axis. Here's the y-axis over here. The lines are hitting here and here. So they're not in the same spot. So the y-intercepts, we say, are different. So you have parallel lines, they never cross, therefore there's never a solution. That's when the slopes are the same, but the y-intercept are different. This could be found on page 236. Of your book. Then there's a third situation where you might have an equation in two different forms and you end up with having the same line. So in that case, if you have the slopes are the same and they hit exactly in the same spot, you're going to have every answer be an answer. So that's infinite number of solutions. The lines are the same, there's infinite solutions. The slopes are the same, and the y-intercepts are the same. So three situations. If we look here in the example given in your book, this is still on page 236. We look here. We wouldn't even have to graph it once we know this example. If we look at our situations, y equals mx plus b. If we look at the slopes, they are both 2, so we have the slopes are the same. Then we look at our y-intercept. The y-intercepts are different. If that's the situation, the slopes are the same and the y-intercepts are different, which of these cases does it fit into? One solution, no solutions, or infinitely many solutions? Well, you start thinking about it. Look at the picture. They cross at different spots. This line crosses at 1. This line crosses at -3. This line goes up 2 and right 1, up 2 and right 1. So does this line. Up 2, right 1, up 2, right 1, up 2, right 1. They're never going to cross. Therefore, it's no solution. Now we have two other special types of lines here. Two other special situations when graphing a linear function. You may have a vertical line. A vertical line. So a vertical line, x. You just write it as x equals the number where the line crosses the axis. So that's the vertical line. You can see it here. I've drawn it in here. Your vertical line. Vertical means up and down. Or you could have a horizontal line. A horizontal line is y equals the number of the line crosses the axis. So here you have your horizontal line. Now they've given you a integer x equals a, but we're going to put the number in there. So if you look at where this line crosses, which axis does it cross? The x axis. Where does it cross the x axis? Here's 0, here's 1, and here's 2. It's in between 1 and 2. Okay, so we in algebra we want to stay away from integers, so we're going to call this line x equals, instead of 1.5, we're going to call it 3/2. Similarly, here's the horizontal line crossing the y-axis. 0, 1, 2, 3, and 4. It's between 3 and 4, so this is the line y equals, now it's 3.5, but we don't want to write it 3.5. We want to write it as an improper fraction. So we're going to write it as 7/2. The line y equals 7/2. Everywhere on this line, y is 7/2. Everywhere on this line, x equals 3/2. If we talk about their slope, the slope of the vertical line is undefined. Be careful. I've put this as a fraction, but this is not a line that rises 3 and runs 2. It's not a slope. The slope of this line is undefined because it rises. The slope is equal to 3/2 over 0, and you can't divide by nothing or 0. So here we have the slope of the horizontal line is 0. Well, that's okay because here we have the slope equals 0. It doesn't change in the y direction, but in the denominator you have 7/2. That's okay. You can do 0 divided by 7/2, which equals 0. So we saved this last problem here on your homework. We have negative x plus 2 equals -2. We got to use inverse operations. And we need to rewrite this. If we add x to both sides, we get y equals 1x minus 2. So that's equation 1. The slope equals 1, which is 1 over 1. And you start at 0, -2. 0, -2, rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. And then set your straight edge down. Draw your best line. Now the other line is a special situation. It's the line y equals 2. So we look up here. Y equals lines are horizontal, so I need to make a horizontal line through 2. So I just go to 2, put my straight edge horizontal. And there's your line y equals 2. Identify where they cross, and there's your answer. The answer is 4, 2. So I need to check. Equation 1. I'm going to put, this is your x and a y. Negative 4 plus 2 equals negative 2. That's negative 2 equals negative 2. Check. And then equation 2 is a simple case. Y equals 2. Is the y coordinate 2? Yes. So that one checks. So then we turn this into the last of your homework problems. Page 239, this is homework. We need to use inverse ops here. We end up with equation 1, y equals 2x plus 4, and then equation 2, y equals 2x, and there's nothing there, so we can put plus 0. Now we have to look at our, before we graph it, let's look at our situation. Slope-intercept form. The slopes are the same. And the y-intercepts are different. When this is the situation, what do we have? One solution, no solutions, or infinite solutions? And the truth is, slopes are the same. I'm going to go back to where the slopes are the same, but the y-intercepts are different. We have no solution. And then we need to graph it. So we graph it. We start at 0, 4. This one we start at 0, 0. And the slope is equal to 2, or 2 over 1. This slope is 2, or 2 over 1. So now we graph each one. Equation 1, 0, 4. It rises 2 and runs 1. Now that goes off the grid, so I'm going to need to change that to negative 2 over negative 1. So I could go down 2 and left 1, down 2 and left 1. Down 2, left 1. Now I'm going to pick another color, and on the next color we have to decide. I'll use orange. The next one we're going to do is graphing this line. Now, is this line going to intersect the orange line? Is it going to intersect the blue line? Is it going to be on exactly the same as the blue line, infinite, or is it going to be parallel, so no solution? Let's graph it. 0, 0, rise 2, run 1, rise 2, run 1. I ran out. I could also go down 2 and left 1. So we see after we're done graphing this, we have a parallel line. No solution. And we have our last problem. This will end it here. Again, you need to do inverse ops. And here you have to distribute. I get y equals 4x plus 8. And here I end up, when I distribute, I end up with y equals 4x plus 8. I notice that the slopes are the same and the y-intercepts are the same. So what is that when we have the slopes the same and the y-intercepts the same? Is that one solution, no solutions, or infinite solutions? And if we go back to our sheet here, slopes are the same, y-intercepts are the same, it's the same line. So you have infinitely many solutions. Infinite solutions. Now I'm going to introduce a symbol for you for infinity that you can use in place of the word infinite. So you can just draw this symbol. And all you have to do is craft the last line. They both start at 0, 8. And the slope of both m equals 4, which is 4 over 1. So if we go to 8, then we have to rise 4 and run 1. Now look, these go by 2s and these go by 2s. So if I rise 4, I can only go in between 0 and 2 here. I can also go down 4 and left 1. Down 4, left 1. Connect these dots and you're done. Same line. And that's the end of Unit 4, Lesson 1, Part B.